Okay, for step 3 in this example, let's take a look at those refiner results and explore them a little bit. See if we can sort of make some sense out of the different things that we proposed as input variables and the outputs that we reported. So again, we'll look at the design grid, kind of think about what we want to show as the axes and the weighting values on the scatter plot, and maybe look at the design table to figure out the precise values that gave us some of the things that look most interesting. So here we are looking at, this is just sort of the scatter plot of the top radius and the middle radius, which again is interesting in terms of the inputs, but not necessarily showing us what would be most useful. If I'm sort of most interested in this whole notion of, I want to sort of get the solar insolation, can kind of think about that versus the cost of the kind of building. Okay, you can start to see something sort of really interesting happening here. There's this weird banding kind of going on where different sort of test cases give us these kind of, just kind of like values as we think about that. So it's interesting that we can get the same amount of solar insolation for a whole number of different total costs. So relative to that, we might think about, there's this kind of threshold over here of a certain amount of solar insolation and how we could achieve that. There's a second level and kind of a third tier up there also. You can kind of think about really why that is. It might have to do with the number of sides. It might have to do with the rotation right now. There's definitely something interesting to explore there. Okay, if we look at trying to make some sense within there, we can sort of think about, well, really, what would we do there? Those all have fairly similar solar insolation values. They're all big there across there. Let's go back and try maybe cost per insolation. Okay, this is kind of an interesting way of looking at it. You can sort of see that the cost for providing the insulation down at this point is much lower. This is much higher. That's because the cost is just much higher for this relatively same level of insulation. It's kind of interesting to think about it that way. If I go to just the cost per insulation and do that in decreasing value, you can sort of see that this point right here is actually the all-time, well, actually I take that back. That's the highest cost per installation. That's not what we want. That's way over here. Let me kind of flip it over. This is our lowest cost per insulation. Kind of right in there. What else could we think about here? We could think about, trying to test this, like, oh, there's other ways. You could think about, for example, that cost per insulation, okay, versus the total cost. Maybe if I tried contrasting that basically with the whole issue of the top radius. Now, that seems pretty random. I don't really see much of a pattern in there. Let's try it versus the top rotation. Again, not really interesting. Well, let's at least sort it out a little bit. Here's the top radius. Again, it's sort of scattered here. It looks like as the radius changes, the higher costs are here. That's not really changing all that much. Let's come back over here. Top rotation. Again, it looks like, we're getting slightly higher values as we move kind of to bigger and bigger rotations. I think we're basically, as we have those bigger rotations, we're getting more and more surface area stretched out. Okay, as opposed to these. But again, this is all in the spirit of ultimately just helping you kind of see some different trends that might be interesting and that you might want to explore. Because you can say that you're going to find just sort of a optimum value or what you can consider to be an optimum value, but even more importantly, as you start to understand these behaviors, hopefully it's giving you some ideas of either how to refine your model to show things a little bit better, give you more accurate results. Yeah, or just, think about, how to, kind of redefine your analysis a little bit better to kind of get at the issues that you're really kind of interested in optimizing for your design. Okay, within this, we can go ahead and, again, switch on over to look at the specific cases. So for example, if you just want to say, oh, what is the case that has the, pardon me, actually that's the direction I do want it in, you know, the lowest cost per installation, you can sort of see it goes anywhere from 4 cents all the way up to, oh, like 6 cents based on the things that we studied here. We can sort of see that there's some that are relatively equivalent. You can sort of see just basically how things sort of stack out. Actually, it makes sense per the graph. That's the way we're plotting in the y-axis. So all these are the kind of lowest cost per installation. Those are the highest cost ones up there. Okay. So you can definitely kind of be looking at these. Another thing to think about is really whether you want to consider kind of changing some other variables. We were just changing the radiuses and one of the twists. Maybe another factor would actually be sort of more impactful. Or even start to consider that maybe changing one of the constants that you're putting in there. If you had a different sort of cost metric, if you were in a different location in the world where the sun was stronger or not as strong, again, you get different sort of results. So again, just use this as information to kind of fuel your creative design process. You know, it's really all about just, you know, helping you make informed design decisions. Okay, super. So let's leave this example here as just sort of some space to kind of continue to exploring and take a look next at lots of different examples of different sorts of optimization problems that you might be able to apply Refinery to.